Imagine a story without a beginning, an existence without a start. Sounds impossible, right? But what if the universe, the grand cosmic theater we inhabit, has always existed? Yes, you heard it right. A universe without a big bang, without a singular event marking the dawn of time and space. This notion may seem counterintuitive, especially when the conventional understanding of our universe's origin is deeply rooted in the Big Bang theory. But there's an alternative hypothesis that dares to challenge this conventional narrative. It suggests a universe that is timeless, a universe that has always been and will always be. This hypothesis presents a universe that defies the very concept of beginning. It's a paradigm shift, a whole new way of looking at the cosmos. Today, we delve into this mind-bending concept, an eternal universe. Most of us have heard of the Big Bang theory, the epic explosion that supposedly gave birth to everything we know. This theory suggests that roughly 14 billion years ago, all matter, energy, and even space itself originated from a singularity, a point of infinite density and extreme heat. The Big Bang wasn't a typical explosion, as one might imagine. Instead, it was more of an expansion, a rapid stretching of the fabric of space-time itself. Picture a balloon being inflated, with the universe growing just like the surface of that balloon. This theory has shaped our understanding of the universe's past, present, and future. It's given us a framework to explain the cosmic microwave background radiation, the abundance of light elements like hydrogen and helium, and the large-scale structure of the cosmos. It's also given us a glimpse into the universe's future, predicting an ever-expanding, cooling cosmos that will eventually succumb to entropy and the inexorable march of time. However, the Big Bang theory does leave us with some unanswered questions. For instance, what was there before the Big Bang? Was there even a before in a conventional sense? And what caused the singularity to expand in the first place? These are questions that have puzzled scientists and philosophers alike. Moreover, the Big Bang theory, while incredibly successful, is not without its challenges. There are mysteries like the horizon problem and the flatness problem, which the theory struggles to explain without invoking a brief but extremely rapid period of expansion known as inflation. So, while the Big Bang theory has provided us with a compelling narrative of our universe's history, it's not the only story in town. There are alternative theories, alternative ideas about the nature of time and space, and the origin of everything we know. But what if this isn't the whole story? What if the universe didn't have a definite beginning? What if it's always been here, forever existing in one form or another? These are the questions we'll explore in the next scene, so stick around as we delve deeper into the mysteries of our universe. Could the universe be like a book with infinite pages, with no first page to turn? Now this might sound like a paradox, but it's a concept that some scientists and philosophers have toyed with, the idea of an eternal universe. A universe that has no distinct beginning or end, but has always been. This concept challenges our typical understanding of time. We're accustomed to thinking of time as linear, with a clear beginning and end. But what if time isn't linear? What if it's more like a circle, forever looping back on itself? This is where quantum physics comes into play. Quantum physics, the branch of physics that deals with the smallest particles in the universe, suggests that our conventional understanding of time might not be the whole story. It proposes that at the most fundamental level, the universe exists in a state of quantum superposition. This means that all possible states of the universe, from the past, present, and future, coexist at once. In this quantum world, the distinction between past, present, and future becomes blurred. For instance, quantum entanglement, a well-documented phenomenon, allows particles to instantaneously affect each other, regardless of the distance between them, defying our traditional understanding of time and space. If we apply this concept to the universe as a whole, it could imply that the universe exists in an eternal now. This is a universe where time, as we understand it, doesn't exist. Instead, all moments are occurring simultaneously. This perspective is mind-bending, to say the least, and it raises a lot of questions. If the universe is eternal, what does that mean for the concept of causality, the idea that every effect has a cause? If there was no first cause or beginning, how does that change our understanding of existence? The eternal universe hypothesis challenges our understanding of time and existence. It invites us to view the cosmos not as a linear narrative with a clear start and finish, but as an ever-unfolding quantum superposition of states, a cosmic symphony playing all its notes at once. It's a paradigm shift that could change how we perceive our place in the cosmos. What if our universe is just one among an infinite number of universes? This question thrusts us into the realm of multiverse theories, which posit that our universe might be just one small bubble in a vast cosmic foam, endlessly bubbling up and popping into existence. The first of these theories is the infinite universe theory. It suggests that the universe we live in is so vast and unending that every possible configuration of matter and energy happens not just once but an infinite number of times. It's a mind-bending concept, isn't it? Next, we have the bubble universe theory, also known as eternal inflation. It proposes that our universe is just one bubble in a cosmic ocean of bubbles, each with its own laws of physics. These bubbles are born from a state of eternal inflation, continuously expanding and giving birth to new universes. Then there's quantum multiverse theory, a child of quantum mechanics. According to it, every decision, every chance, every quantum possibility spawns a new universe. Imagine an infinite number of universes where every conceivable outcome of every event plays out. Last but not least, we have the string theory multiverse. String theory, the theory that suggests everything in the universe is made of tiny, vibrating strings, also lends itself to a multiverse. In this scenario, different universes could exist in different dimensions, all cohabiting the same space without any awareness of each other. These multiverse theories, while speculative, offer a new perspective on the nature of our universe and its existence. They challenge our perception of reality and push the boundaries of our understanding. If these theories hold, then perhaps our universe could be eternal in the grand scheme of things, with new universes continually being born. These theories open up a whole new dimension of possibilities. So let's keep exploring, keep questioning, and keep pushing the boundaries of our understanding. After all, the universe is a big place and there's always more to discover. So is there any evidence for an eternal universe? And what do scientists think of this idea? As we delve into this, we should note that the evidence is not straightforward and is often the subject of intense debate. Let's start with the observational evidence. Some scientists point to the cosmic microwave background radiation as possible evidence of an eternal universe. This radiation, a faint echo of the Big Bang, permeates all of space and is remarkably uniform. Could this be a snapshot of an eternal universe, one that has always been there and always will be? Then there are large-scale structures in the universe. Galaxies, clusters of galaxies, and even larger structures form intricate cosmic webs. These structures could be the result of an eternal universe, a universe that has had infinite time to form and evolve. But what about the debates and controversies? As you might imagine, the concept of an eternal universe has sparked some lively discussions among scientists. Many argue that the Big Bang theory, with its singular beginning, provides a more satisfying explanation of our universe's origins. Critics of the eternal universe hypothesis point out that it struggles with the problem of entropy. If the universe has existed forever, they argue, why hasn't it reached a state of maximum entropy? A state of no return, where all energy is evenly distributed. On the other hand, proponents of the eternal universe suggest that entropy might not be an issue if the universe is cyclical, with periods of expansion and contraction. In this view, each cycle could effectively reset the entropy, allowing the universe to exist forever without reaching maximum entropy. The concept of an eternal universe also faces philosophical and metaphysical challenges. For instance, if the universe has always existed, what does that mean for causality, the principle that every effect has a cause? The concept of an eternal universe is still a hot topic in cosmology. As scientists continue to gather evidence and refine their theories, we can look forward to more exciting debates and discoveries in the years to come. The idea of an eternal universe isn't just a scientific question, it also has profound philosophical and cultural implications. In many ways, the concept of an eternal universe tugs at the very fabric of our understanding of reality. It is a notion that transcends science, extending into the realms of philosophy, religion, and culture. In philosophy, for instance, the idea of an eternal universe raises intriguing questions about cause and effect, about existence and non-existence. If the universe has always been, then what does that mean for our understanding of causality? Perhaps we need to reconceptualize our notions of cause and effect entirely. In the realm of religion and spirituality, the concept of an eternal universe can be both conflicting and harmonious, depending on the perspective one chooses to embrace. For some, the idea that the universe has no beginning and no end contradicts traditional narratives of creation. Yet for others, an eternal universe may align with beliefs in a divine or cosmic order that exists beyond human comprehension. Culturally, the idea of an eternal universe can be awe-inspiring. It invites us to contemplate our place in a cosmos that is infinitely vast and endlessly old. It humbles us, reminding us of our insignificance in the grand scheme of things, while simultaneously filling us with a sense of wonder and curiosity about the mysteries that the universe holds. The eternal universe hypothesis, therefore, is not just a scientific proposition. It is a philosophical puzzle, a religious conundrum, and a cultural marvel. It challenges our perceptions, provokes our thoughts, and stirs our emotions. It compels us to question, to explore, to seek answers, and in doing so, to grow and evolve. As we continue to grapple with the mysteries of the cosmos, let us remember that the journey is as important as the destination. The quest for understanding is what drives us, what defines us, what makes us human. And in that quest, we find not just answers, but also questions. Questions that push the boundaries of our knowledge and our imagination. The eternal universe hypothesis invites us to rethink our place in the cosmos. From the Big Bang theory to the eternal universe hypothesis, our understanding of the universe's origin is a fascinating journey. We've delved into the depths of cosmology, exploring the birth of the universe as we know it, and questioning if it even had a beginning. We've considered the Big Bang theory, the prevailing explanation for how our universe came to be. This theory paints a picture of a universe that began from an infinitely dense, hot, and tiny point, expanding and cooling over billions of years to form the cosmos we see today. Then, we ventured into the realm of the eternal universe hypothesis. This challenges the conventional narrative of cosmic origins, suggesting that the universe has no distinct beginning but has always existed in one form or another. We've stepped into the quantum world, where the laws of physics as we know them take on strange and fascinating forms. Here, time might not even be a fundamental aspect of reality, opening the door to a universe that's eternal. We've journeyed through multiverse theories, imagining a cosmos where our universe is but one of countless others, each with its own laws and parameters. In such a scenario, the concept of an eternal universe gains a new dimension. We've touched on the philosophical implications of an eternal universe, pondering over questions of causality, existence, and the nature of time. We've also explored the cosmological models that propose an eternal universe, grappling with the challenges posed by entropy. We've looked at the observational evidence and theoretical support for an eternal universe, including cosmic microwave background radiation and large-scale structures. We've also examined alternative explanations for these phenomena that might be consistent with an eternal universe. So has the universe always existed? The answer might be out there, waiting in the stars. As we continue to explore the cosmos, we are certain to uncover new insights and revelations that will bring us closer to understanding the true nature of the universe. For now, the journey continues and the mysteries of the universe remain as alluring as ever.